Hello student, welcome to my channel Learn Physics. Today I will be discussing the one-dimensional motion and solve the numerical of H.C. Verma. My today's discussions are displacement, distance, velocity, speed, acceleration, retardation, and various types of H.C. Verma numerical related to this. This video will be extremely helpful to build up your concept in motion. Please like, share and comment on it. And if you are new, subscribe my channel to get the better mark in NEET, main and advanced. So let's start. First of all, distance. The path length traveled by a moving body is called distance. It is a scalar quantity. It is always positive. For a moving body, it is always increasing, it never zero and never negative. Okay, now displacement. Displacement is the shortest distance between initial and final point. Suppose a particle moving along this path. Okay, so this is the initial point, this is the final point. O is the initial point, A is the final point. The shortest distance between O and A is the displacement. It is a vector quantity directed in the direction from initial point to final point. It may be zero, positive or negative. For a moving body, it for a moving body it may increase or decrease. Okay. Now difference between distance and displacement. First of all, distance is the path length traveled by a body. Or a displacement is the shortest distance between initial and final point. If d be the displacement and s be the if if s be the distance and r be the displacement, so r by s always less than equal to 1. Okay. Now difference between displacement and distance. It is the path length traveled by a moving body. It is the shortest distance between initial and final point. It is a scalar quantity, it is a vector quantity directed from initial point to final point. It is always positive, it may be positive, negative or zero. For a moving body, distance always increasing. For a moving body, displacement may increase or decrease. Okay. Now some H.C. Verma numerical related to distance and displacement. Question number 1. A man has to go 50 meter due north, 40 meter due east, and 20 meter due south to reach a field. What is the distance he has to walk to reach the field, and what is his displacement from his house to the field? Okay. Now look at this. Person moves 50 kilometer due north. Okay, no problem. This is the 50 kilometer due north. Then 40 kilometer due east. Look at this. This is the 40 kilometer due east. Okay, no problem. And finally 20 meter due south. Look at this. This is the 20 meter due south. Okay, this is the initial position. Then this is the 50 meter due north. Then this is the from AB is the 40 meter due east, and finally BC is the 20 meter due south. Now what is the distance he has to walk to reach his field? Look at this. This is the 50 meter, this is the 40 meter, and this is the 20 meter. So distance traveled by the man S equals to, this is the 50 meter, this is the 40 meter, and this is the 20 meter. Okay. So look at this. This is the 110 meter is the distance traveled by the man. Now, what is the displacement from his house to the field. Look at this, displacement is the shortest distance between initial and final point. Okay, so look at this is the displacement. Okay, so OC is the displacement. Now look at this from here to calculate the OC. Look at this, suppose this is the C dash. So here OCC dash is a right angle triangle. So look at this is the 20, so this is also 20. Okay, so look at this is the 30, this is the 40. Therefore, displacement OC equals to, look at this is the 30 square plus 40 square. Okay. So look at this is the root under of, this is the 900 plus 1600. So this is the 50 meter is the displacement of the person. Okay. Now look at this question number 2. A particle starts from origin, goes along the x-axis to the point 20, 0. Then return along the same line to the point minus 20, 0. Find the distance and displacement of the particle during the t. Look at this. Suppose this is the line which is x-axis. Okay. Now this is the origin. Okay. The particle moves from this to this. This is the 20, 0. No problem. And then this is the minus 20, 0. Okay. So look at this is the initial position, this is the final position. So displacement is the, this is the minus 20 to 0. So this is the minus 20 meter is the displacement. What is the distance travel? Look at this is the 20 meter, this is the 20 meter, and this is the 20 meter. So 60 meter is the distance traveled by the particle. Okay. An old person moves along a semicircular track of radius 40 meter during the morning walk. If he starts at one end of the track and reaches the other end, find the distance covered and the displacement of the person. Look at this here, radius of the semicircular track, this is the 40 meter. So the distance travel S equals to, this is the circumference by r. So pi is the, this is the 3.14 and r is the 40. So look at this is the 12.56 into 10. So this is the 125.6 meter is the distance covered by the old person. The shortest distance between initial and final point is the displacement. Therefore, displacement r equal to, this is the 2r, so this is the 80 meter. Okay, understood? Next. Now speed. The distance traveled by a moving body in unit time is called speed. If s be the distance traveled in time t, then speed v equal to s by t. So here v equal to s by t. Therefore, distance travel s equals to, this is the v into t, no problem. And time taken to travel the s distance with speed v, this is the t equal to s by v. These three relations are very important to solve numerical related to speed. Okay. Now average speed. Average speed is the total distance traveled by total time taken. If S1 distance travel in time t1 and S2 distance travel in time t2, then S1 plus S2 divided by t1 plus t2. Where speed v1 equal to, this is the S1 by t1 and speed v2 equal to, this is the S2 by t2. If you replace S1 and S2 in terms of v1 and v2, the average speed becomes, look at this is the S1 equal to v1 t1. Look at this is the v1 t1 plus v2 t2 divided by t1 plus t2. This is the another expression of average speed. Now, if t1 and t2 is replaced by s1 and v1 and s2 and v2, then average speed, look at this speed can be written as, look at this, average speed can be written as, look at this is the S1 plus S2 divide by, now T1 equal to, this is the S1 by V1 and T2 equal to S2 by V2. So look at this is the S1 by V1 plus S2 by V2. Okay. So this is the another expression for average velocity. Now we have to calculate average speed in equal time. That is, a particle moves with speed v1 for time interval t and speed v2 for time interval t. Okay. So same time interval for velocity v1 and velocity v2. So in this case, here average speed becomes, look at this, here v1 into t plus v2 into t divided by t plus t. So look at this, here v1 plus v2 into t divided by, this is the t plus t, so this is the 2t. Okay, no problem. So look at this, here t and t cancel out, so average speed in equal time, this is the v1 plus v2 by 2. Okay, this is the very important relation for you. Now we have to calculate the average speed in equal distance. That means a particle moves distance s with speed v1 and another same distance s with speed v2. Here same distance s and s. So here average speed in equal distance, look at this using this relation, here s plus s, this divided by s by v1 plus s by v2. So look at this is the 2s into 2s, here 1 by v1 plus 1 by v2. So look at this and this cancel out. So look at this is the 2 v1 v2 divided by, this is the v1 plus v2. Okay, look at this is the average speed for equal distance. Okay, understood? Look at this is the HC Verma example. A man walks at a speed of 6 km per hour for 1 kilometer and 8 km per hour for next 1 kilometer. So look at this, here equal distance and two speed v1 equal to 6 km per hour and v2 equals to 8 km per hour. So for equal distance, the average speed, this is the 2 v1 v2 divided by v1 plus v2. Look at this, v1 is equal to 6 km per hour and v2 equals to 8 km per hour. So look at this is the 2 into 8 into 6 divided by 8 plus 6. So look at this is the 2 into 48 divided by, this is the 40. Now look at this is the 7. So look at this, 48 by 7, almost 7 kilometer per hour. Okay, no problem. Next, now average speed for given time interval. Suppose a particle moves from this point S1 in time t1. Again S2 distance from the same point in time t2. So in the time interval t2 minus t1, the particle covers the distance s2 minus s1. Therefore, average speed, this equal to, this is the s2 minus s1 divided by t2 minus t1. So look at this is the delta s by delta t. Okay, this is the average speed for given time interval delta t. Now instantaneous velocity. Instantaneous velocity v is the limiting value of average velocity when time delta t tending to 0. Therefore, instantaneous velocity, look at this, delta t tends to 0. Here delta s by delta t, this equal to ds by dt. Okay. Now look at this, an example of AC Verma. The distance traveled by a particle in time t is given by s equals to 2.5 meter per second square t square. Here s equals to, this is the 2.5 t square. Okay, find average speed of the particle during the time 0 to 5 seconds. So look at this average speed during the time 0 to 5 seconds. This is the S5 minus S0 whole divided by this is the 5 minus 0. Now S5 means the distance traveled in 5 seconds. So look at this is the 2.5 into 5 square. Now S0, this is the 2.5 into 0 square whole divided by this is the 5 minus 0. So look at this here 2.5 into 25 by 5. So look at this is the 12.5 meter per second with the average speed. Now instantaneous speed, look at this the instantaneous speed v equal to ds by dt. So look at this here s equals to 2.5 t square. So look at this here 2.5, this is the d dt of t square. Now dt of t square, this is the 2.5 power of 2. So 2 into this is the t to the power 2 minus 1. So this is the 2.5 into 2t. So this is the 5t. Now here t equal to 5 second. So look at this is the 25 with the instantaneous velocity at the time t equal to 5 second. Okay, understood? Next. Now velocity. Now velocity is the displacement divided by time taken. So look at this velocity v equal to this is the displacement by displacement divided by time taken. Okay, look at this. If r1 and r2 be the initial and final position of a particle, then velocity v vector, this is the r2 vector minus r1 vector divided by t. Okay, it is a vector quantity directed in the direction of displacement. So look at this for a straight line path, v equal to this is the r2 minus r1 by t. If r2 and r1 is very close to each other, then v equal to we can write this is the delta r by delta t. This is also known as average velocity. Now uniform velocity. If displacement of a particle be equal in equal time interval, then it is called uniform velocity. If the displacement of particle is not equal in equal interval of time, then it is called non-uniform velocity. Okay, look at this. If velocity be uniform, then speed also be uniform. Because velocity has both magnitude and direction, but speed only magnitude, as velocity uniform means its magnitude and direction both uniform. So speed is also uniform, but reverse is not. If the motion in straight line path, then uniform speed means uniform velocity. If a body moves in uniform speed in a car path, then velocity is not uniform. Okay. Now instantaneous velocity. Instantaneous velocity is the limiting value of average velocity when time delta t tending to 0. So instantaneous velocity v is equal to this is the limit delta t tends to 0. Here delta r by delta t. So look at this is the dr by dt. Okay, no problem. Next. Now a H.C. Verma numerical relating to velocity. A table clock has a minute hand 4 centimeter long. So look at this radius of minute hand, radius is the 4 centimeter long. Find the average velocity if the tip of a minute hand between 6 am to 6:30 am. Now look at this. Look at this. The position of minute hand at the 6 am, this position, and at the 6:30 am, the position, and at the 6:30 am, the position here, this. Okay. Therefore, the displacement of the tip, look at this, the displacement of the tip of the minute hand This is the 4 centimeter plus 4 centimeter. So this is the 8 centimeter. So average velocity v equal to this is the 8 centimeter divided by time taken. Time taken, look at this is the 630 minus 6. So look at this is 30 minutes. Therefore, the velocity is the 8 by 30 centimeter per minute is the velocity of minute. Now look at this, the average velocity between 6 am to 6:30 pm. Now look at this 6 am to 6:30 pm. Here displacement is same, but time interval is 12 hour 30 minute. So here velocity v dash equals to this is the 8 centimeter and this is the 12 hour 30 minute. So this is the 12 whole half hour. So look at this is the 8 into 2 divided by 25. This is the centimeter per hour is the average velocity of the tip of the minute hand. Okay. Now HC Verma numerical 3. It is 260 km from Patna to Ranchi by air, 320 km by road. An aeroplane takes 30 minutes to go from Patna to Ranchi, whereas a deluxe bus takes 8 hours. Find average speed of the plane. Now, average speed of the plane. Look at this. The distance traveled by time taken. So look at this. Distance is the for plane. This is the 260 km and time taken 30 minutes. That is the half hour. Okay, so look at this. This is the 5 to 20. So this is the 520 km per hour is the average speed of the aeroplane. Now, average speed of the bus. Look at this. The average speed of the bus. This is the 320 km divided by 8 hour. So look at this. This is the 40 km per hour is the average speed of the bus. Now, average velocity. Look at this. The average velocity. Now look at this, the average velocity v dash, this equal to, now average velocity for the aeroplane is same as that average speed, because in both cases the aeroplane travels the straight distance 260 km, but average velocity of the bus, this is the displacement, this is the 260 divided by 8. So look at this is the 65 by 2. So look at this here, 32.5 kilometer per hour is the average speed, is the average velocity of the bus. Okay. Therefore, average velocity and speed for aeroplane is same in both cases, but average velocity of the deluxe bus is 32.5 kilometer per hour and average speed is the 40 kilometer per hour. Okay. Now question number 4. When a person leaves his home for sightseeing by his car, the meter reads the meter is 12,352 km. When he returns home after 2 hours, reading is 12,416 km. What is the average speed of the car during this period? And what is the average velocity? Now look at this, the average speed v equal to, this is the 12416 minus, this is the 123, this is the 52. Okay, divide by time taken is the 2 hour. So this is the 2. Therefore, look at this minus this is the 48 plus 16. So this is the 64. Okay, so 64 by 2. So this is the 32 kilometer per hour is the average speed. And what is the average velocity as the initial and final position of the person is same, that is at the home. So average velocity this equal to 0. Okay. Now acceleration. The rate of change of velocity with respect to time is called acceleration. If v1 vector be the initial velocity and v2 vector be the final velocity during the time interval t, then acceleration a vector equal to, this is the v2 vector minus v1 vector whole divided by t. For a straight line motion, A equal to this is the V2 minus V1 and divided by T. Now average acceleration. In time interval delta t, if the change of velocity be delta v, then average acceleration this equals to delta v by delta t. Okay. Now instantaneous acceleration. Instantaneous acceleration is the limiting value of average acceleration when time delta t tending to 0. Therefore, instantaneous acceleration A, this is the limit delta t tends to 0. This is the delta v by delta t, that is dv by dt. Okay, in vector form, A vector equal to this is the dv vector by dt vector. Now A equal to this is the modulus of this is the dv vector by dt. So this is the magnitude of total acceleration. Now acceleration A equal to dv by dt. This is the rate of change of magnitude of velocity is acceleration. This acceleration is known as tangential acceleration. This acceleration is produced only change of velocity, but this acceleration produced both change of velocity as well as change of magnitude of velocity. Okay. Now uniform and non-uniform acceleration. If the change of velocity of a body be uniform in given interval of time, then acceleration is uniform. If not uniform, then it is the and change of velocity is not uniform, then acceleration is not uniform. Okay. Now some numerical relating to acceleration. Look at this question number 5. An athlete takes 2 seconds to reach the maximum speed of 18 km per hour. What is the magnitude of his acceleration? Look at this here. Final velocity v equal to this is the 18 into 5 by 18, that is the 5 meter per second. Initial velocity u equal to 0. Time t equal to 2 seconds. Therefore, acceleration a equal to v minus u by t. So look at this. This is the 5 minus 0 by 2. So this is the 2.5 meter per second square is the acceleration of the athlete. Okay. Now a numerical relating to velocity and acceleration. The position of a particle moving along axis is given by x equals to a t cube b t square plus ct plus d. The numerical value of a, b, c, d, t 1, 4, minus 2 and 5 respectively. The SI unit are used. Find the dimensions of a, b, c, d. Look at this. The dimension of a is the dimension of x by dimension of t cube. So dimension of a, look at this, the dimension of a, this is the LT minus 3. Dimension of b is the dimension of x divided by dimension of t square. So dimension of b is the LT minus 2. Dimension of c is the dimension of x by dimension of t. So c is the dimension of LT minus 1 and d has dimension L. Because added term have same dimension, so dimension of x equal to dimension of at cube equal to dimension of bt square equal to dimension of ct equal to dimension of d. Okay. Now look at this. If we put the value of a, b, c and d, we get this. Okay. Now question number 2. The velocity of the particle at 4 seconds. Now, if we differentiate x with respect to time t, you get velocity. So, v equal to this is the dx by dt. So, look at this. This is the 3t square plus 4 into 2t minus 2 into 1 plus 0. So, this is the 3t square plus 8t minus 2 is the acceleration. Now, if we put the t equal to 4, we get velocity after 4 seconds. So look at this, the velocity after 4 seconds This is the 3 into 4 square plus 8 into 4 minus 2. So look at this. This is the 3 into 4 square. So this is the 48 plus this is the 32 minus 2. So look at this 30 plus 48. So this is the 78 meter per second is the velocity of the particle. Now, what is the average velocity during the time interval t equal to 0 to t equal to 4? Now, average velocity during the time interval 0 to x equals to 4, 0 and t equal to 4. Now, x4 minus x0 divided by this is the 4 minus 0. Now, look at this. If we put t equal to 4, we get, look at this is the 64 plus 64 128 minus 8, so 120. So look at this is the 125, and if you put t equal to 0 you get 5, so this is the minus 5 divided by 4. So look at this is the 120 by 4, so this is the 30 meter per second. Now average acceleration during the interval t equal to 0 to t equal to 4. Now you get velocity v equal to, look at this is the 3 into t square plus 4 into 2t minus 2. Therefore, this is the 3t square plus 8t minus 2. So look at this, the average acceleration A equal to, this is the v4 minus v0 divided by 4 minus 0. Now v4 means this is a 3 into 16, 48. 48 plus 32 minus 2. So this is the, look at this is the 78 minus, look at this is the minus 2 divided by this is the 4. So look at this is the 80 by 4. So 20 meter per second square is the average acceleration. Okay. Now objective 1 of AC Verma. Look at this question number 3. A particle has a velocity u towards east at t equal to 0. The velocity directed along east. It acceleration towards west. Look at this, acceleration towards west. Okay, and is constant. Let x and xp be the magnitude of displacement for first 10 second and next 10 second. Okay, look at this, first 10 second. As velocity, look at this, as u and a are not known, so we can't decide which one greater, xa greater or xb greater. So option D is correct. The information is insufficient to decide the relation of xa and xb. Now question number 4. A person traveling in a straight line path move a uniform velocity v1 for some time and with uniform velocity next equal time. What is the average velocity? You already know the average velocity in equal time. This is the v1 plus v2 by 2. Okay. Now MCQ 5. A person traveling a straight line moves with a uniform velocity v1, a distance x, and with uniform velocity v2 in next equal distance. For the next equal distance, the average velocity is given by, you already know, for equal distance, the average velocity in a straight path is the 2 v1 v2 divided by v1 plus v2. Okay. This is the objective 2 of AC Verma. This is the multiple correct option. Consider the motion of the tip of a minute hand of a clock in 1 hour. Look at this. Its displacement is 0. Yes, the initial and final position of tip of the minute hand in 1 hour is same. So its displacement is 0. It is the correct option. The distance covered is 0. No. Distance is not 0. It is not correct. The average speed is 0. No. The average velocity is 0. As displacement 0, so average velocity also 0. Therefore, A and D are correct. Now look at this. A particle moves along x-axis. Look at this. X equals to u t minus 2, a t minus 2 whole square. The initial velocity of the particle is u. Now look at this. First of all, you have to calculate velocity. Velocity v equal to, this is the dx by dt. Therefore, this is the u into 1 plus this is the 2a into t minus 2. If you put t equal to 0, you get v equal to u minus 4a. So initial velocity is the u minus 4a. So initial velocity is not u. So this is incorrect. The action of the particle is a. No, 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 no. If we look at this, if we differentiate v, we get acceleration dv by dt. Look at this. This is the 2a. So acceleration is 2a. This is the correct. Now at t equal to 2, the particle is at origin. If you put t equal to 0 in this equation, you get x equals to 0. So particle is at origin. Therefore, C and D are the correct option. Now question number 3. Pick the correct statement. The average speed of a particle in a given time is never less than the magnitude of average velocity. Yes, the magnitude of average speed greater than equal to magnitude of average velocity. Look at this. It is possible to have a situation d by dt, d v vector by dt not equal to 0, and this is the 0. Yes, this is this is due to only change of magnitude of velocity, and this is due to change of magnitude as well as direction. For a uniform motion in a circular path, this is 0, but this is not 0. So it is correct. The average velocity of particle is 0 in time interval. It is possible that the instantaneous velocity never 0 in that interval, as instantaneous velocity is velocity in a given instant. So instantaneous velocity never 0 if average velocity is 0. So look at this. This is also correct. Now, the average velocity of particle moving on a straight line is 0 in a time interval. It is possible that the instantaneous velocity is never 0. Yes, in that, yes, it is correct. Okay. So here B, C and D are correct. Look at these 4. An object may have varying speed without having varying velocity. No, 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 no. Varying velocity without varying speed. Yes, in a circular motion, it is possible. Non-zero acceleration without having varying velocity. No, 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 no. Not possible. Non-zero acceleration without having varying speed. Yes, it is correct. So here A, so here B and D are correct. Now MCQ 5. Make the correct statement for a particle going on a straight line. If the velocity and acceleration have opposite side, the object is slowing down. Yes, it is okay. If the position and velocity have opposite side, the particle is moving towards the origin. If the velocity is 0 at instant, the acceleration should be 0 at that instant. Yes. If the velocity is 0 at that instant, the acceleration should also be 0. No, 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 not necessary. If the velocity is 0 for a given time interval, the acceleration is 0 at any instant within the time interval. Yes, it is correct. Therefore, A, B and D are correct. Many thanks for watching this video. This video will be extremely helpful to build up your concept in physics. Please like, share and comment on it. And if you are new, don't forget to subscribe my channel. Okay, thank you.